Hi, Algebra 2 students, and welcome back to Miss McGuire's classroom. Today, we are going to be discussing Unit 1, Lesson 4. And today's topic is all things functions. So today is going to be kind of like an introduction to functions. And hopefully this is a review of everything that you learned about functions in Algebra 1. So nothing should be too new, per se. This is just a friendly reminder. Make sure that your first and last name and the period and the date are at the top right-hand corner of your notes, and make sure that you're writing down everything that I'm writing down, all the examples, and showing all of your work as we go. So today's objective is I will be able to identify and define functions and find outputs and inputs of functions. So I will be able to identify and define functions and find outputs and inputs. So FCTS is short for functions. So from now on, you're going to see either FCTS or just FCT, and that's short for function, shorthand, right? I'm going to write that in place of the word function from now on, so we don't have to just keep writing out the same word over and over again. So what is a function? So a function is a relation where every input has exactly one output. And we'll talk about what inputs and outputs mean in just a little bit, but it's really important that you emphasize exactly one, not one of many or one of whatever, but there's exactly one. So every single input has exactly one output. It can only map to one output. So let's talk about what that means in the form of examples. So if we look at example 1, remember the definition of a function is a relation that where every input has exactly one output. So if we look at example 1 here, in this first one, you've got a list of all these inputs. You've got a list of all these outputs. Now notice the inputs are being mapped to the output that they belong to. So 0 is being mapped to -2, but 0 is also being mapped to 1. 1 is being mapped to 2. 2 is being mapped to 1, and 3 is being mapped to 4. So 1, 2, and 3 have exactly one output each. They each map to exactly one output. However, the number 0 maps to 2 outputs. Therefore, this relation is not a function because one of the inputs maps to more than one output. So this is not a function because 0 maps to 2 outputs. And how many outputs are inputs allowed to map to when they are a function? Exactly 1. So now you're going to tell me about these other 2 relations. You're going to tell me if they are functions or not, and you're going to tell me how you know. So pause the video and then press play when you're ready to check your work. So if you look at this next example, this graph of a circle, is this circle a function or not? Well, if you look at the input, so if you look at the input of 2, 2 has an output of whatever this number is, like 3.5. And this is, well, -3.5. This input maps to 2 outputs. We'll look at the input -3. It also maps to 2 outputs. So a circle has a whole bunch of inputs that map to more than one output. So this is not a function. so not a function because multiple inputs have more than one output. All right, let's talk about the third part of this example. So if you look at this example here, 1 maps to D, 2 maps to C, and 3 maps to C. So what did you decide? Was this a function or not? I would say that this is a function because every input has exactly one output. 2 and 3 share the same output, but outputs are allowed to have multiple inputs. Inputs just can't have multiple outputs. I know it's kind of confusing. So, yes, it is a function because each input has exactly one output. All right. Moving on to example 2. So example 2 focuses on function notation. So function notation is a way that you can rewrite an equation to represent that it is a function, because in that equation, every input has exactly one output. So what is function notation? Function notation is simply f of x. And function notation can be interchanged or replace y. So if you have, you can say, like, if you have y is equal to 2x, you can rewrite that as f of x equals 2x. So y, oops, apparently I grabbed the eraser instead of the highlighter. So y gets replaced with f of x because that equation is a function. Every x value will get you a different y value and only one y value. I mean, every x value will get you a unique y value. So it is a function. Now, the way you read this is f of x. So this says f of x. So now we're going to rewrite example 2, a through f here, using function notation. So y is equal to negative 2x. Using function notation, we would write f of x is equal to negative 2x. So why don't you go ahead and pause the video and press play when you're ready to check your answer. So let's just double check your work. So for part B, you should have gotten find x when f of x equals negative 10. I just replaced y with f of x. 0 equals 3x is still 0 equals 3x. There's no y. There's nothing to change. Remember, f of x replaces y. Part D becomes f of x equals negative 2 times 4 plus 1. I just realized I put my parenthesis in the wrong spot there. All right. Part E is f of x equals 7. And part F is solution x f of x is equal to 1, 2. So part F is just written as an ordered pair. Remember your x and your y values. Make up an ordered pair. Okay. Now we're going to talk about an example 3, inputs and outputs. So our inputs are what we plug into the function. So what you plug into the function. And normally what we plug into the function are the x values. So our inputs are usually the x values, what you plug into the function. Then your outputs are what you get out of the function. So after you plug x into the function, you get the y value. So your outputs are what you get after plugging in the inputs. So it's like what you get out of the equation. And normally those are always your y values in a typical function. So let's practice that. So part A of example 3 here says for f of x equals negative 2x plus 5, find what is the output for the inputs negative 3, 0, and 1/4. So our first input is negative 3. The next one will be 0. and the third one will be 1/4. So when I plug this into my function, I'm going to get f of -3 is equal to -2 times -3 plus 5. If I simplify that, I'm going to get -2 times -3 is 6, 6 plus 5 is 11. So I get f of -3 equals 11. 11 is my output. Let's plug in 0. So f of 0 is equal to -2 times 0 plus 5, which simplifies to 0 plus 5, which is 5. So f of 0 is equal to 5. Notice both times that I did this, I replaced this x and this x with -3. I placed this x and this x with 0 when I plugged it in. So instead of saying f of x, I can say f of -3 or f of 0. What is the function of -3 in that equation? The function of -3 is 11. What is the function of 0 in this equation? The function of 0 is 5. Now let's find the function of 1/4. So f of 1/4 is equal to -2 times 1/4 plus 5. We've got a little more to simplify here. -2 times 1/4 would be -2/4 plus 5. I need to get that 5 with the same denominator as the first fraction, which is 4. So I'm going to multiply that by 4. And I get -2/4 plus 20/4, which is 18/4, which simplifies to 9/2. So f of 1/4, the function of 1/4 is equal to 9/2. So now for part B, you have a different function. You have the function f of x is equal to -4x plus 1. You have the outputs -2, 0, and 5. So why don't you go ahead and find all the outputs for those given inputs for that function. You can go ahead and compare your work to mine. You should have gotten f of -2 equals 9, f of 0 equals 5, and f of 5 equals -5. Moving on to example 4. So in example 4, it's a little different than example 3. Example 3, we were given the inputs and then we needed to find the outputs. But for this example, we're given the output and we need to find the input that would give us that output. So for f of x equals 3x plus 1, f of x equals -1. So we're going to find the input that gives us -1 as the output. Now notice, this equation is equal to f of x. Well, what do we know f of x is equal to? -1. So we're just going to use some substitution. So I'm going to replace f of x with -1, and that's equal to what f of x is equal to, 3x plus 1. Now we're going to solve for x. So -2 is equal to 3x. So x is equal to -2/3. So the input -2/3 would give us the output of -1. So f of -2/3 is equal to -1. And that's how you're going to write your final answer. You're going to put it in terms of the function. What would you plug in as your input? And then what would you get out? What is that function equal to? All right, go ahead and do example B without me. Press pause and then press play when you're ready to check your work. As you can see from my work, I said 8 equal to the function -1/2 x minus 2. Then I solved for x and I got -20. So my final answer should be that f of -20 equals 8. The input, -20, maps to or gives us 8. All right, let's do the last example. So for example 5, you're going to find the outputs of the function by reading its graph. So remember, our x values are the inputs, our y values are the outputs. So we can represent inputs and outputs as an ordered pair. So if you look at where x is -3 on this graph, x would be -3, we'd get -4. So that means that the ordered pair -3, 4. So f of -3, if I plug in -3 into this function, what will I get for my y value or my output? I'm going to get 4. Now do the same for -2, 0, and 2. I'll give you a hint for -2. For -2, you're going to find where that point is on the graph. So when x is -2, it leads me to this point. If it helps, think of that point as an ordered pair and find your output. As you can see, for f of -2, I got -2.5. For f of 0, -1.9. And for f of 2, 0.3.